Hi, everyone. First up, I wanted to thank, this is my second time. I feel very honored to present at IMUG. The last time was, we've actually been debating when it was. It was pre-pandemic, so it feels a lifetime ago. And I think at that point, I had been speaking mainly in connection to the book that Tex had referred to, The Chinese Typewriter. And this book, The Chinese Computer, started at the same time as The Chinese Typewriter. And so all told, it has occupied about 16 years of my life. And so it was very, very good to just get it out of my system and get it into the world. So here are the two. Between these two works, both of which are on MIT Press, The Chinese Typewriter effectively begins in the midpoint of the 19th century and begins effectively with the question not of how do you fit a non-alphabetic writing system onto a keyboard, but how do you fit it into effectively Morse code? How do you build a Chinese telegraph code? And then I pursued a comparable question: how do you fit across the telegraph code, the typewriter, and then eventually into the realm of the computer. The most recent book, which came out a few months ago, The Chinese Typewriter, could have been called The History of Chinese Input Systems, but then no one would have picked it up off the shelf. But really, it is an attempt to think about human-computer interaction in a non-alphabetic framework and the implications of that, not just for global computing, but also for the future of writing. I try to argue in the digital age. After a pre-intro, I suppose, the book begins in 2013 in Henan in China at a Chinese input competition. This is a classic typing competition where competitors sit down, they're given the same text, and then they have to best one another in a feat of speed and accuracy. And as you can see, these are just Windows machines. These are off-the-shelf Windows machines. There's nothing particularly special about them. And what I like to ask, I won't ask the exact same question in this audience because I'm afraid that someone might know the answer and ruin it. But I will often ask the question, what do you think the winning score was? How many characters per minute do you think the winner of this competition in 2013 achieved? And I'll explain that the way in which this is a screencast of the actual winner of this. My understanding is that this may or may not work, and it doesn't matter. Oh, it does. Good. And as everyone in this room, I understand, knows, and everyone online, but a great many people on this planet do not understand, is that you have in all Chinese human-computer interaction, you have this input method editor, this middleware that is operating and intercepting between the program application and the interface, and that what this person is actually doing on their keyboard is being captured in these rapid ephemeral keystrokes that are captured and then are annihilated as soon as the user identifies each of their desired single character or 2 character or even 3 and 4 character sequences. And after having explained the basics of how one uses a QWERTY keyboard in order to input Chinese, inevitably there'll be some rascal in the audience who'll say 1,000 words a minute just for fun because they kind of understand what I'm after. But most people will say that sounds like an incredibly cumbersome system. There's so many different steps to that. There's this recursive process, 120 words per minute, 130 characters per minute, 150 characters per minute, something along those lines. And then comes the moment of the great reveal, which is that the winner of this competition clocked 221.9 characters per minute, or 3.7 Chinese characters every second. Now, this room knows better than most that it's very difficult to kind of convert characters to words, but there are ways to do it. You can sit down with a skilled and experienced translator of Chinese text, and they can give you a rough ballpark. You can do other things like take standard text of the United Nations and compare them if you want. However you do the math, the answer is that that is far faster than anything that's ever been clocked in English in, say, the Guinness Book of World Records or what have you. And so then the question becomes, if we are honest and say that the Chinese shurufa, this human-computer interaction of input, is this seemingly complex, at least when you describe it on paper, recursive process. There's a pop-up menu, there's a composition screen, there is the code that a user must internalize and learn. Accounting for all of those steps, how is it possible that the maximum speed is also greater than what for the entirety of the late 19th century and the 20th century and most of the 21st has been heralded as the greatest of all possible worlds, the world of immediate English language human-computer interaction? What could be better than the cat bit the dog without any recursion, without any pop-up menus? What could be better than that? And it turns out that in terms of speed and accuracy, at least when you compare the Olympic athletes of input, not just average, the Olympic athletes of different languages, it turns out that surprisingly, all of these additional steps and recursive properties somehow get us to a place where human-computer interaction can happen faster. Now, I personally don't care about typing speeds. I type the speed I type, and I have no desire to type any faster. But if we take the 19th century, 20th century obsession in the Western European and the American world with speed and accuracy, that this is the mantra of efficiency, Michael Addis's technology is the measure of men, then you have to present this stat back to the Latin alphabetic Euro-American world and say, interesting, huh? This is your game you chose, and what has just happened in the story? What is the story of human-computer interaction in this immediate and hyper-mediated realm? That's really what the book is about. So I'm going to borrow from a kind of timeline that was presented or put out for this talk by a pair of Chinese computer scientists and kind of software engineers in the late 1980s and 1990s. I'll give you the translation here, who talks about, by the late 1980s, already a quite audacious claim. At a time when the top speeds of Chinese shurufa had not even come close to 200 plus characters per minute, but they could already see the future. They already see where, the Moore's law of this, so to speak, of where this was headed. And he wrote, at present, input speeds for modern Chinese have clearly already surpassed speeds for Western languages. Into the future, as character and compound-based processing undergo even deeper research, and as even more ideal character libraries, talking about this is so cool, of even higher quality are created, we have every hope that users with leisurely keystrokes will be able to reach or greatly outpace the speed of human speech. Another individual put it very differently in the very same year. The towering doyen of Chinese linguistics, who trained most of the generation of the most important linguists of China, certainly in the Anglophone world, and not to throw any shade, but he wrote this in the exact same year, a very different diagnosis of what the future of Chinese input was. In word processing, we normally input alphanumeric symbols and print out text expressed in the same symbolic code. This is very simple and highly efficient, especially when the operator is a skilled typist. This is my bold, but I think it's worth bolding. There is not, and I believe can never be, as efficient a system for inputting and outputting Chinese characters. DeFrancis is wrong. It proves to be wrong, and his colleague, who we probably never met in life, proves to be right. So kind of the question of the book is, what happened? How do we get to this particular place? There is another individual he actually wrote earlier, 1986, in the founding, I'm not sure if I'm, oh good, he's not obstructing it, in one of the founding issues, the founding issue of one of the most important information processing journals in mainland China. He outlines the same kind of future that his colleague Zhang in 1989 had sort of, but he breaks it up into these different eras or epochs. And each of these eras is defined or categorized according to the then challenge that human-computer interaction developers were facing in the case of Chinese. First is, how the hell are we going to get one character on the screen? How do we solve that problem? Then it's how do we get two character compounds? whether it's place names or in modern Chinese, most words are not single characters. They're made out of 2 Chinese characters. And then longer passages, sentences, 句. And then finally, writing itself, 文. And he divides this into a temporal chronological phases of when each of these was overcome and when he thought the next one would be. And what's amazing about this, 1986, is how prescient this was, that this is largely played out. And this is the architecture that I'm going to use for the purposes of this talk to walk through it. So this first era, character, then compound, then sentence, then writing, is the way we're going to walk through this. So begin with the most basic question. This is the one that I write about in the Chinese typewriter. How do we get a single character across the wire? How do we get a single character onto a TypeScript page? This was a phenomenally difficult problem that consumed linguists, entrepreneurs, engineers, eccentrics all around the world, not just in China or the Sinophone world. But how do we do this? I'm not going to dwell on this because this is what I spoke mainly about last time I was here. But suffice it to say that this question of how do we do this was highly parameterized by the prestige and power and colonial might of the Euro-American world at this point. And above all, the prestige of the keyboard-based interface. This idea that there is something about a keyboard that every modern language needs to have. A keyboard is some sort of essential interface of modernity. And this dates back, obviously, well before computing, to the era of the mechanical typewriter. As everyone here, I'm sure, is familiar, this is a post-United States Civil War technology where precision engineering firms inspired by new kinds of text technologies are retrofitting effectively their manufacturing plants from the manufacture of one kind of precision instrument, that is weapons of war, into very different kinds of precision engineering outfits like sewing machines and typewriters. That's why we have Smith Corona, Smith Wesson. That's why we have Remington rifle, Remington typewriter. In the early years of the typewriter, it was a sort of wild west of the question of how does one write with type? This idea, how do you write with pieces of type? There were typewriters that had no keyboard at all. There were typewriters in which the upper and lower case for case-based writing system were on one keyboard. There were typewriters that were manipulated, held by one hand. And then there were typewriters that resemble what we have inherited basically for the last century and a half, which is the single shift keyboard. This very diverse and weird ecology of the 1870s, 80s, 90s collapsed around the 1900s. And the only game really left in town, with the exception of like the Mignon typewriter and a few index typewriter leftovers, was the single shift keyboard typewriter, which had huge implications for writing systems around the world. I talk in the typewriter extensively about the kind of disaster that the single shift keyboard typewriter was for Thai, for Burmese, for a variety of writing systems, where suddenly the starting point of the single shift keyboard really made largely Western engineers make some pretty drastic, almost forced internationalizations of writing systems around the world. The one writing system, however, that Remington tried and failed to break into, IBM tried and failed to break into, Olivetti tried and failed to break into, and the list goes on, is Chinese. For the simple reason that there was no way to accommodate the writing system and still keep the manufacturing plant identical. They would have had to rethink their entire starting point if they really wanted to break into the Chinese market, and they just weren't willing to do that because they did break into the Arabic market, the Thai market, and various others. But Chinese was left. Now, Chinese had a typewriter. It was, if this typewriter had existed in the 1870s, it would not have been a freak of nature, because there were, in the Western world, there were typewriters with no keyboards. But by the 20th century, the idea of a typewriter with no keys sounds like a Zen koan. Like, what's the sound of one hand clapping? And so the entire history of the Chinese typewriter and all its manufacture looked like this. It's an index typewriter, it's known as. It's a tray bed of 2,450 potential loose metal slugs. that you could pick up this tray bed and dump out all the type. And the way that you type is you use your left hand to grab the green knob in the front there. You move the entire tray bed left and right. You use your right hand, as long as it's not broken like mine is, to grab the top right green knob, and then you pull it left and right, and the entire plate moves and thing. And then eventually you bring the character you want under this metal thing in the middle there. You push down on the lever, a little metal finger pokes the slug up, it gets sucked into and locked into that rectangular metal case, inked, strikes the plate, and then the character is spit back out into the hole left over by its absence, okay? So then the question becomes, and there's a whole training regimen, I talk about this in the book, I'm not gonna go into it, but there's typing institutions about how you learn to type. This is actually gonna come back. You don't do étude, like, because you're not using all 10 fingers. It's sort of like typing with one finger. You're just moving across space. And so distance equals speed effectively. And we'll come back to this because this is going to be the origins of predictive text, by the way, and natural language arrangements of taxonomy. But something strange, it's not as if anyone in the Sinophone world or the Chinese-speaking world, and certainly outside of the Chinese-speaking world observing any of this, respected this machine. Nobody respected this machine. It was reviled, ridiculed. It was the subject of just really techno-racist kind of imagery. The stuff is quite shocking when you present it. And so there still was this, and the prestige of the keyboard had not diminished. The idea that China still isn't modern, we don't have a keyboard-based typewriter, we can't have a pale approximation, was still driving many people to think about how can we change human-machine interaction in this. And this is what really drove the development of a prototype, which was debuted to the world in 1947, the Minghuai Chinese typewriter, prototyped by Lin Yutang, the famous writer and kind of cultural ambassador, cultural commentator, and sort of amateur linguist and so forth. And this is him and his daughter Lin Taiyi at the machine. It was prototyped with the machine assistance of Remington, and also Murray-Feldman linotype was in the background. Now, I just spent the first 5 minutes or 10 minutes of my talk saying that there can never be a Chinese typewriter with a keyboard, and now you're looking at a Chinese typewriter with a keyboard. So thank you all, good night, and I'll try what's happening. If you were to sit down at this keyboard and start depressing keys on it, you would hear gears moving, but nothing would appear on the page. And then you might push another key down and you would hear more gears move, but nothing would appear on the page. You might think it's broken. But after 2 keystrokes, one from the upper bank of keys and one from the lower bank of keys, in that rectangular window, it's literally a glass window on the top of the machine, he called it his magic eye, he patented it separately, up to 8 potential character matches appear. And then in your third and final keystroke, you depress one of the number keys, which you can see on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, to select. It was a mechanical input method editor. This is the first input method editor in history. But it was metal. It was made of metal. The reason for this, so this is what input is search writing. It is writing through the act of search. This is primarily a character retrieval machine, an inscription machine secondarily. The reason is that Lin got his start with this question decades earlier in a very cool but very geeky and awesome debate in the 19-teens and 20s about what's the best way to organize a Chinese dictionary, or a filing cabinet, or a library card catalog. We don't have A through Z, so how do we compete with alphabetic scripts in terms of the efficiency of modernity and so forth? There were dozens and dozens and dozens of competing ideas about how best to do this. This was the so-called 简字法问题, the character retrieval problem. This is where some really famous, actually later input systems came from. Lin created one of his retrieval systems that, again, he wasn't thinking of typewriters, he was thinking of card catalogs, but he made somewhere in the 30s, based on the archival evidence, somewhere in the 30s, he turned a corner and he said, wait a minute, what if we could take what we're thinking about in terms of retrieval and bring it into the service of inscription? And then that's what led to Minghuai as effectively a retrieval inscription machine. The keyboard is a proprietary input system. This is the predecessor of people who make their own keyboards. He sat down and made up a bunch of proprietary shapes. If you know Chinese, you'll know that many of these are not like anywhere in the history of Chinese lexicography or the Chinese language. He just made them up. My favorite is on the bottom. There's a horse cut in half. And that's because he's doing some sort of taxonomic smoothing. He needs to develop a system where the depression of any two strokes effectively graphically describes up to but no more than 8 Chinese characters, but ideally no fewer than like 5 or 6, because otherwise you have a lot of wasted space. And then inside the machine is a metallic hard drive. Is these octagonal metal bars with characters etched on them, bundled in like Ferris wheels of Ferris wheels of Ferris wheels of Ferris wheels, and they're like rotating by virtue of thing and bringing the certain things into type zone. So from the machine fails. The book is full of the story of Chinese computing is failure, 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 juggernaut. And so the first like 9 chapters or 6 chapters or so, they're like, where is this going? But again, I spend most of my time dealing with the failures of history because it turns out, as in the case of Min Kuai, although this failed, there is never another serious human-machine or human-computer interaction person who departs from this model, except with a really interesting exception in the 70s. But most of the time now we're in the realm of input. So this is the first pop-up menu, but it's physically part. And the pop-up menu stays in the realm of, I'll talk about the IBM machine and maybe in Q&A I'll come back to this, a prototype, very similar. It's hard to see it here, but this is the first Chinese computer, the Sinotype, developed by the Graphic Arts Research Foundation under the direction of MIT electrical engineering professor Samuel Caldwell, a student of Vannevar Bush, the advisor of Huffman, who changed his life one day and became interested in Chinese language. But in his machine, there's the second pop-up menu ever. And from that point on, all Chinese human machine and computer interaction is a cybernetic feedback loop. There is always 2 windows in Chinese, pretty much, again, with the exception of the 70s, which I'll talk about, a composition window and a selection window. And it's a recursive process. So a departure from the model of immediate human machine or computer interaction that was so fetishized from Remington really onward. There's another pop-up menu. And then eventually the pop-up menu, this is one of my favorites, is literally like a separate monitor was served as the pop-up menu, and then you have the composition menu. This is the Sinotype 2, the later instantiation of the machine in its demonstration in Shanghai. And then eventually they're brought together through, this is the first instantiation of a Chinese text processor on Mac by the late Bruce Rosenblum. It was the OS that was custom built by Bruce. And one of the reasons, interestingly, that they chose the Mac, I want to say the Mac 2, yeah, I have to go back to my notes, is because of its popularity among gamers. And that the bottom part of the menu, because it was, you could have basically split the screen between graphics and text. And so on the bottom in a game, it would be like run, jump, various text commands, and then you have the game. In their case, they're like, this is perfect for us because the top of it is graphics, which is the only way we're going to do Chinese fonts, and the bottom can serve the purposes of an input pop-up menu. So this is the first softwareization, really, of the pop-up menu, but it's with us forever. So effectively, from the first problem, the first chapter, the Zi chapter of this 1986 prediction of the future, took a really long time. I mean, this is a sort of a century story of how do we get just one darn character to kind of function and work. But then the curve gets faster. It's sort of like the next stage gets shorter and shorter and shorter over time. This is the question of the compound. As I mentioned, and I believe there are Chinese speakers, maybe in the audience or in the room, you'll know that in modern Chinese, a large percentage of the Chinese vocabulary is not made of one character at a time. It's 2 characters, 学生, 会议, 睡觉, whatever it might be, 开始, 2 characters. And so along the way, and we'll get there eventually, is that computer engineers started to say, well, maybe we can kind of harness that, exploit that factor, that maybe character by character is not the best way to do this. Now, what's interesting about this is it takes us back to the typewriter again, because when this machine was developed and first put into manufacturing in the 1920s onward, from the 20s and 30s and 40s and the early 50s, the way that you organized the characters on the tray bed was, simply put, dictionary order. You don't really need to know how a Chinese dictionary works, just know it's a dictionary order. And what that means is it bears no relationship to words that actually go together in real speech. Apple, aardvark, like, don't go together. And so if I'm writing 学生, I might be jumping around. I might be going, you know, 学生, 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 and because 学 is down here where the dictionary tells me it is, and 生 is all the way over here, and that distance is directly a relation to speed, or the lack thereof. Now, the other part of it, which I already alluded to, is that these characters are loose. They're loose slugs. You can dump them out. And the reason for that is that it was designed to be customizable. The Chinese typewriter from the 20s onward was designed to be customizable. Why? Well, because 2,450 characters are not all Chinese characters in the lexicon. And so you need to have a certain flexibility, because if you work in a bank and I work in a police station and you work in a law firm and you work in a trading company, our common usage characters will differ. Some of them will be exactly the same, but let's say your boss's name is some really weird surname that isn't common. You're writing his name all the time, so you're going to have that slug. You're going to go to a character foundry. The same people that make movable type slugs say, cut me this character, please. And they'll say, sure, give me 5 yuan. And you walk out and you put it in your tray bed. And so it's good. And it changes over time. Common usage changes over time. My favorite example, and I talk about this in the book, is the character Mao, which by itself means a follicle of hair, but it's also the surname of Mao Zedong. And so in the 1930s, Mao is a secondary usage character, and in the 1950s, it gets promoted to the center of the tray bed as a very commonly used character. Now, the reason that this is important, this flexibility and this kind of inherent in the dictionary order, is that sometime in the 1950s, and we don't know exactly who started talking about this, but we know that it kind of started and then spread like wildfire, is effectively some typesetters, compositors working in newspaper plants, and typists said, well, this is kind of stupid. I'm writing Mao Zedong over and over and over again, and Mao is here, and Zi is here, and Dong is here, and that is distance and speed. Why don't we effectively dump all the characters out and rebuild the tray bed so as to achieve adjacency of characters that go together in actual speech? Once you do that, you have 2,450 factorial possibilities, which is more atoms than there are in the universe. Which also means that to make one of these tray beds, you could have infinite variability between different typists. And that's what they did. And there are guidebooks on how to do this, but every single one of the tray beds that I tracked down, which was very fun. I spent 10 years tracking down these kinds of tray beds. I found some in UNESCO and some in the United Nations and some in Shanghai. They were all different, but they all had the same principle of let's put things together that go together. And they took this really, really, really far to the point where I decided to, for my readers, visualize it this way, as a heat map that is representational of speed. This is a 1930s era tray bed organized by the dictionary method. And what the color represents is that if a cell is white, that means that there is one character in the neighborhood of that slug that it could be meaningfully connected to form a real Chinese word. If it's red, that means it's got a lot of neighbors it can be connected to. And if it's black, that means none of the neighbors can be meaningfully connected to it, apple, aardvark, to produce something. This is the speed of a 30s era. And this, I'll come back to this, is the speed of the 50s. They tripled the speed of the tray bed without any application of electricity just by creating this natural language arrangement. The reason that this is important is that early computer engineers were aware of this from the word go. They knew this was essential to the speed of Chinese, and they started baking this logic into Chinese text processing effectively from the very beginning of the process. So I'll jump ahead a little bit here just in the interest of time to show you one example of this, which is this is a reproduction of a text input screen from the 1980s. And what you'll see here is the top of it is, again, the composition window. So this person is writing the People's Republic of China, 中华人民共和国. But on the bottom, you don't see any of the text input because this person has just completed the text process. But then you see 2 rows on the bottom. And what the middle row there, that's got like 0, 1, 2, 3, 4, you can translate that as connected character or associated character, or quite literally connected thought character. And so because the most recent character inputted was guo, which means kind of country or state, the next 10 are all characters that can be meaningfully connected with guo to make another Chinese word. So guojia, country, guofang, national defense, guoji, international, guonei, domestic, guowai, international, and so forth. And then the next row, the bottom row, is associated thought or associated or connected thought compound. So these are 2 character possibilities that can meaningfully connect with the last character entered. And so you don't even have to input it. You can just choose 0, 1, 2, 3 or A, B, C, D, and you can accelerate the process. Now, if anyone here reads Chinese, you'll know that it's a little bit clumsy. It's not super smart yet because it would be very weird to have 中华人民共和国法, like that doesn't make sense. But this is to say, they're starting to think in this in the 80s already with this system. Does anyone know the Chinese name of the company Lenovo? Lianxiang. It is quite literally named after this practice, connected thought. It was so important that effectively the name of the company that eventually took over IBM's was effectively predictive text. That's the name of the company, you could say. That's how important this was to Chinese computing from the outset. This has gotten super, super, super powerful over time to the point where it's not just the last character and then an anticipation of what comes next. There's all sorts of abbreviations where your actual input string can get shorter and shorter and shorter and shorter. And because of the sort of intelligence baked in and also the back-end repositories and corpora and pool, that the guesses are better and better and better and better. Now, what this means is, again, so from nothing to from character, from how do we do this to a character, from character to a compound, has just become shorter. We're talking about a few years at this point, maybe a decade, let's say. And then the curve just gets steeper from the next point up to the sentence. By the early 2010s, input enters the cloud. The simplest way to put this is the Google search bar, but where it is, guessing that Britney Spears just released an album, so if I write Britain, it's like Britney Spears scandal, or whatever it might be, guessing it. But instead of it being about a Google search bar, it's accompanying you as you do Microsoft Word, as you do email. So this thing that Google released of like suggested replies and all that stuff, way late. This stuff was already being seriously implemented in text applications from the 2010s onward. I gave a talk at the Computer History Museum that also later bore fruit. That was the day I think I got my badge. I'm now a futurist, because then 10 years later some computer scientist said it, so suddenly it means something because it's not a historian saying it. I was like, this is a massive backdoor for surveillance. An input system is effectively a kind of listening device, even if you don't send the message, even if you don't print out the thing. It is a telecommunications thing. You're sending a message through the wire. It is undergoing operations, and lo and behold, someone with a different business card than I sort of made that case, and it just made a really big presence. But it putting aside the question of security and surveillance, this has a huge implication to the point where it becomes possible to enter, and I talk about this in the book, an abbreviation. I think I have this example. Yeah, the abbreviation XMYJJ, which is not a meaningful Chinese phonetic Hanyu pinyin phrase, but will successfully, without like a gimmick, without pre-training this, will give you the stanza of a Tang Dynasty poem. And that's because way back, I talk about this in the book, I'll just glance over it, is that the back-end dictionaries that are being baked into these input systems are getting bigger and bigger and bigger and bigger. So in the 1980s, there's a a terminology list, a digital terminology list for aeronautical engineering and Chinese traditional medicine and this and this. And now we're getting to the point where the back-end library in, say, Sobo or Baidu or whatever is many millions of entries long and really long, not just place names and personal names, but full passages, full text, and so forth. That is a stable corpora against which any input stream can be matched, and it can inform the guesses that come up in one's pop-up menu. So we're effectively already within, that's a very short span of time, to this place of the cue, the sentence. And that is really how we're getting to the place where in 2013, it becomes possible to clock these kinds of speeds. It's not that the person, the guy who won, is just blazingly fast, although he is. It's because it turns out that the ceiling, the maximum possible ceiling of efficiency and accuracy when you're talking about this is simply much higher in this kind of mediated environment than it is in the immediate human-computer interaction world. And that makes sense. We've actually known that about human-machine interaction since the 19th century, because I'm sure many of you know, in a courtroom, the stenographer doesn't use a Remington typewriter or a QWERTY keyboard. There is no QWERTY typist who can keep up with the speed of speech. It can't be done. And so you use this special device called a steno typewriter, which is effectively the only popular, really, really widely used English input system, because it involves this encoded way of inputting it, and it requires a secondary translation from the coded primary transcript to the natural language secondary transcript. But the benefit of that extra hoop that you have to jump through is that you can keep up with anything and everything that is uttered in that courtroom and produce a good transcript. It's in effect like, unlike the Anglophone world or the Francophone world or the Anglophone world, whatever, where court stenography is a practice used by an exceedingly small fraction of the population. You might think of in Sinophone computing, every single computer user is a stenotypist, every single one. There is no immediate Remington-style typing. In fact, there is no typing in Chinese at all. There is only input, this recursive process. Now, what I spent a lot of the book, and I'm coming in for a landing now, and I'm excited for this discussion. I spent a long time looking at, well, the screen recording of this guy's victory in the 2013. I slowed it down. I went frame by frame to try to, he's typing so fast that the pop-up menu is too fast to even read. So I just like recorded it and went frame by frame to reconstruct, what is he actually typing? Like, what is he actually doing phenomenologically when he sits in front of this machine? And that's what's on the bottom there. That's what he's actually doing. And then it is morphed into this text above. This is a different part of the test. This is the random character test where this doesn't, if you read Chinese, it doesn't mean anything. And that's on purpose in the test. I spent probably about 10 years trying to decide what to call this kind of writing on the bottom. Is it code? It kind of is, but it's kind of not. Like, it's not meant to hold anything in secret. It's not really an act of encryption in the way that we think of. It's real time. So it's much more like a grocery clerk who knows that the code for cabbage is 5732. It's a lot less like Bletchley Park in terms of code. Is it abbreviation? Is it text speak? Is it? And I sort of went through this inventory of potential terminology to try to find what this stuff is and what to call it. And it has these various features to it. What do we call this? I eventually settled on, I don't like neologism. I normally run away in the opposite direction. But after basically looking at a lexicon of about 100 different terms, decided that none of them really fit the bill, because none of them sort of get at the core features of what we're noticing here. And I tried to inventory. There is no one-to-one relationship between what is typed and what comes out on the screen. There are, in fact, if you jump ahead, an infinite number of input sequences that can produce the same text output. There is this weird built-in recursion in which there's this constant feedback loop. Very importantly, is in bullet point 3 here, the primary transcript. What every single Sinophone computer user is doing is producing a primary transcript that will ultimately be disposed of. It will ultimately be disposed of. Just like the paper tape coming out of the steno typewriter at the trial at Nuremberg, if you go to the archives, that's not what you read. You read the natural language transcript of it, but that's a secondary transcript of what actually that typist was doing, which was this thin paper tape that's coming out in kind of gobbledygook. Same deal in Chinese input and Japanese input and Korean input, by the way, and many other systems. So it's a form of writing in which I calculated that if you tally up all potential Chinese computer users and just assign an average number of characters per day, we're talking about a text transcript larger in size than the entire holdings of the Library of Congress, which is the moment it achieves its goal, burned. It's sort of thrown away as ephemeral stuff, and then what replaces it is the output, the secondary transcript, and that's this bottom. Upon successful completion of the process, it's disposed of, and so there are just various features, I guess, that I wanted to think through and ask the question of what do we call them, and arrived at this idea of hypography. I took that sort of like almost like hyperthyroidism, almost the hypo of it's almost like subtext. It is a semiotic system whose only purpose is not to signify any idea or concept the way that the word cat signifies this mammal that you pet on and that messes with your Zoom meetings. Its pure purpose is to signify another signifier, and then let that signifier do the job of language for you. And as soon as the hypograph succeeds in signifying whatever the character of the word is, it's thrown out the window. I mean, within a matter of sub-seconds in many cases. The reason that I think that this is important, and this is an output of a standard typewriter, I call this English hypography. The Palm alphabet was English hypography. Certain kinds of IDE kind of development environments that have this sort of pop-up recursion menu is another place of sort of rarefied English language hypography. But in the case of Sinophone computing, everyone is a hypographer. There is no one who is not. And this brings us to, I guess, the last, I'll come back to and maybe in the Q&A, come to the missing script of this. Come back to this, this question now, which is the question of when, of writing. When last April, I guess it was, I'm losing track of time, when I was sitting waiting for my kid to sleep and I was looking on TikTok and they're like, there's this thing called ChatGPT coming out and it's a big deal. And then suddenly people talking about this idea of the prompt and the prompt engineer and so forth, and the Anglophone world really reveling in how strange of a concept this was and so forth. And I remember just sitting back in my chair and being like, China has been prompting for 60 years now, in the sense that the same assumption is at play, that what you type is not what you get, that there are different strategies for eliciting what one wants, that you can be better or worse at it, that all these different kinds of things, that mode of a mediated human-computer interaction has been baked into Chinese computing since Sinotype 1 in 1959, but with one major difference, and that would be this. In the case of the first three chapters of that history, the character, the compound, the sentence, the maximum speed limit of the universe in each of those phases is the speed of human intention. It's something I already want to enter into the computer, and I want to do it quickly or even quicker. I want a character, help me make it. I want this compound, now I'm trying to do it. I have a tune in mind now. And then the question becomes, is that a natural absolute speed limit? And the answer, of course, is no. So what is hypography at faster than the speed of human will or human intention? That's generative. That's what we think of as generative. And we know this as human beings. We've sat with a good friend and bounced an idea, and the friend can say to you, like, I think what you should probably do is take this section out of chapter 2 and stick it into chapter 1, and maybe call the book this, and you're like, oh my gosh, Alex, you just saved my bacon. We do that all the time with fellow humans. That's faster than I didn't want to do that. Alex gave me something that was prompted by something I said, but took me in a new direction. Now, of course, this is something that we can do in interaction with the human machine, and with a machine. And then the question becomes, what is the words per minute of such a thing? Does words per minute as a concept simply get thrown out the door? Because now we're talking about words per minute, characters per minute, that is achieving 12,000, 15,000 words per minute, and so forth. The key of it, though, is that the leap that is understood as a leap that's going on right now looks a whole lot less like a leap when you don't view it from the perspective of Latin alphabetic Anglophone human-computer interaction. When viewed in that way, this to generative AI is a huge leap because it's not just the power and speed of it, it's also, it requires the user to imagine a mediated relationship of human-machine or human-computer interaction, which, although everyone understands that every interaction with a computer is mediated, we have to remember that the brilliance of largely Anglophone engineers in the 19th and 20th century dedicated all of their intelligence and ferocity to try to convince the user that it is, in fact, immediate. You type a letter, it's there on the screen. We want you to feel as if there is no mediation going on. And now suddenly, Anglophone computer users and many others are being invited to go back to think about mediation. And this is something that has been part of HCI since the advent, in the case of Chinese computing, and for that matter, a great many other non-Western, non-Latin writing systems overall. So I want to kind of pause there, say thank you, and just let the Q&A drive the rest of the discussion. Questions?
Well, I was wondering if you could, I don't know if people on Zoom, if
They can hear you.
Yeah, okay, cool. I wondered if you could talk a little bit more about the feedback loop, I think you called it the recursive interaction. In both the, mechanical keyboard as well as, the modern ones that you showed, it's a visual cue. Like, I have to be looking at a screen or a prompt or something in order to choose the character. I guess two questions. One is that visual cue, have there been other attempts at making other feedback loops, maybe audio or touch-based ones instead of a visual-based feedback loop? The other question is, can people performing input get to a point where they have maybe you say that some of these dictionaries are trained on millions of lines of text or whatever, and then that implies that maybe they're not the same. Like tomorrow the dictionary could be different than it was today, right? Which implies that you can't actually memorize the keystrokes. Like if you got to a point where we're typing for a long enough time, you might be able to actually memorize the keystrokes without having to look at all. And I was wondering if there's if an even more efficient input mode is just basically go to schools, train for a month, and basically memorize the system without having to have any interaction.
Yeah. That's a great question. So the argument that I think threads through the two books is not out of desire or preference or choice. It's not that Chinese culture prefers mediation in any way that ties to various cultural proclivities. It really is that because from the electric telegraph onward, it was so dominated by Euro-American Latin alphabetic models that it was operating at this structural disadvantage for over a century and a half. That because of that, mediation has been, and the conceptualization of mediation has been front and center in human-machine interaction in the Chinese and many other non-Western languages, but also limited to Chinese, from the 1860s and 70s onward. So, for example, think of a skilled Morse code operator. Someone who is skilled in Morse code in the English language should not be looking at a code book. It's like, hold on, everybody. They should become a kind of human meat transducer where they can hear that and go THECAT. They themselves become the transducer. In the same notion, a skilled typist in the English language is supposed to be able to type blind. If the text is here on one of those little arms, like your boss's memo that you're supposed to make a memo of, you're not supposed to be doing that, right? That's the indication of a bad typist. You're supposed to be able to do this and that. So there is very, very long-standing idea of, again, an immediate way, immediacy as the measure of a skilled telegrapher, a skilled typist, and so forth. In the context of Chinese telegraphy, typewriting, and computing, that was never, ever, ever part of the job description. So Chinese telegraph code operators, the Chinese telegraph code developed in 1870 was a system in which 10,000 Chinese characters were organized in dictionary order and then assigned a unique 4-digit cipher from 0001 to 9999. So in order to send a Chinese telegraph, you would start with the Chinese original. You would use a code book to translate that into a series of 4-digit ciphers, and then you would translate those 4-digit ciphers into Morse code. And so 90+% of telegraphers, Chinese telegraphers, trained ones, would always be using their telegraph code book, like because they wouldn't be able to meet transduce the numbers. They'd hear like they go like 001, 73, so they could do that the way that a skilled person. But then you got to look it up. And what I talk about in across the book is, okay, if mediation is gonna be part of the game, if it's unavoidable in some ways, we are best served by making that mediation be as fast as possible. And so, for example, when editors and publishers of the Chinese Telegraph Codebook, they tried to make different like mnemonic devices. They paginated the book such that the page number was the first 2 digits of the code. They just tried to make the mediation as fast as possible because we know that mediation is kind of where it's at. And then as we go into it, every inventor of a Chinese input system, and there's still people, patenting their inventions as we speak right now. As we speak right now, someone is in their room in Beijing with a dictionary inventing a new input system. What they're doing is just playing totally in the realm of mediation. What is a better way to do this mediation? Now, having said all that, there are some figures in the story who, for whatever reason, either because they're kind of just eidetic memory or savants or something like that, do get to a place where they have memorized the Chinese Telegraph Codebook. They're nicknamed like living dictionaries and things of this nature. There's a fella, he went on to become the head of the Chinese Academy of Social Sciences, but he was on the Long March with Mao. And he was the telegraph operator, and for whatever reason, he didn't have to look up stuff in the book. He was like, for some reason, that good. But even that's a weird exception. So in theory, there are case studies and examples of people who do live this world in an immediate way that more resembles the Latin alphabetic ideal of immediacy, but they're very few and far between. And the vast majority of people, like the guy who wins, there is no way his eyes are not darting back between the composition window, the pop-up menu, and back. He's not looking at the keyboard. He knows where QWERT is. He knows that part. He's internalized that. He would never have achieved those speeds if he's doing that on his keyboard. But like, if you were to do eye tracking analysis on a Chinese computer user or someone using a Chinese input system versus the Latin alphabet, the saccadic movement and the fixations of a Latin alphabetic eye movement study would be this. A Chinese saccadic movement or eye movement study would be this. Over time, and that's not a sign of a bad typist or inputter. That's just the way it works. So the first question, very briefly, to my knowledge, I'm sure I never want to say never, but I have not seen outside of the realm of disability technology. Outside of the realm of disability technology, I have not seen serious alternative experiments with, non-visual feedback loops. But I'm sure that they exist, and I would bet my bottom dollar that they probably exist in the realm of disability technology. Everyone here knows the origins of T9 input, right? T9 input on Nokias and Samsungs back in the day, that was originally a disability technology meant to be worn as eyeglasses, so-called the OWL. for someone who maybe is in late stage ALS or Lou Gehrig's, or basically it's almost ideally for Stephen Hawking. It was meant to be an eyeglass worn eye interrupt with eight possible directions of the eye to look, but that fed into a very, very sophisticated disambiguation algorithm that then along the way someone said, wow, a sighted person could also use this technology, and that became TGIC Incorporated and T9 Input. That is what, like $1 billion invention. So I would never say never, but I have not seen it, but I hope it exists. I'll take two so that I'd be more honest with my time. I'm sorry, I get very excited about this stuff. Yes.
So one thing I think when you talk about the typewriter history, what's the impact of Japanese? Because Japanese also using around 1,000 Chinese characters, right?
Yep.
I believe Chinese introduced used a lot of Japanese technology at that time, so that you didn't mention. Second thing is about looks like you must be talking about the mainland China. You haven't talked about the history of the typewriting of the Hong Kong or Taiwanese, which is totally, I believe they use totally separate technology. They took totally different paths. That you, one thing I'd like to know. Another thing is regarding that cloud, what's that called? Cloud typing?
Yeah, 原输入法.
Yeah, you mentioned that so-called that the typing, that their server in fact is in mainland China. So whatever write type will be served saved in China. It's kind of privacy risk, right?
I spoke about that. You remember the surveillance? That one.
Yeah, I would never use it. It's kind of not transparent. I mean.
Yeah. So quickly, so the last point I spoke about, yes, there's you can, on YouTube, the title of the talk at the Computer History Museum is How to Spy on 600 Million People. You can see it there. The Japan story, if you do pick up the Chinese typewriter, there's a whole chapter called Controlling the Kanji Sphere, which is about Japan in the context of mechanical typewriting. The short story there is that there were two effectively species of Japanese typewriters, kana typewriters, in which Remington, Olivetti, all the major Western typewriters actually did make inroads. There is a Japanese kana, Remington, Olivetti, and so forth. And then there are kanji typewriters, in which, once again, no typewriter manufacturer globally ever made inroads into, for the same reason that they didn't make inroads into China. During the war, from even before, but from the mid-1930s, and then completely accelerated with the full-scale invasion of the entire West Coast in 1937, extended to the end of the war in 45. Japan dominates all Chinese and kanji typewriter manufacturing, to the point where the leading Chinese typewriter in mainland China and in Taiwan, which then of course is a Japanese colony, is a Japanese manufacturer. In the 1950s, the machine that goes on to become the exemplar of a mechanical Chinese typewriter in mainland, the double pigeon machine, the shuangge, is a fangzao. It's a copycat, explicitly copycat model on the Wanneng Japanese typewriter from the 1940s. So yeah, that becomes super embroiled there. If you're interested in that, if you don't want to get the book, there's a Journal of Asian Studies article that I talk about that, but then there's a chapter in the book. The more important part with Japan is, in the context of input, is that when everyone thinks of the Nixon visit and the beginning of rapprochement that in 72 that eventually becomes normalization of relations, Sino-American relations in 79, is that a few months after the Nixon visit is a visit with the Japanese prime minister, and that's a sort of thawing of relations with Japan. That then opens the floodgates for a kind of reuniting of Taiwanese, mainland Chinese, Japanese computer scientists, mathematicians, HCI researchers, meeting for the first time ever at some of the foundational East Asian conferences on this subject. And one of the most important exchanges or interchanges between the Japanese and all of the Chinese contingents was on the basis of input, specifically that Japanese engineers had to deal with something that Chinese, as complex as Chinese input is, it kind of pales in comparison to at least one problem with Japanese input, which is kana-kanji conversion. This idea that, okay, it's not that I just have to figure out what kanji I want, I also have to figure out from contextual clues if this is even kanji in the first place. So I say dozo yoroshiku onegai shimasu, and every dozo onegai, every time the machine has to say like, wait, I think this is kana, wait, I think it's kanji again, I think it's kana, I think it's kanji again. That's irrelevant in theory to Chinese, except that the math of that, whether it's basically applied probability and so forth, the math of that is foundational to Chinese phonetic input. I didn't talk about this, but Chinese input from the first Chinese computer in 1959 all the way to the early 1990s, input is dominated by structure-based input, by input where you're using the letters of the QWERTY keyboard to explain the structure, the shape of characters, not the sound. Pinyin input is there are engineers in the 70s or 80s saying this is the worst of all possible worlds. We will never use pinyin input. It's terrible. For various reasons I talk about in the book, eventually in the 90s, people take another hard look at it and they say, let's give this another shot. When they do, the math that they need to support an IME for Chinese phonetic input is heavily influenced by this exchange with Japan. And so that's another place where it's really important. I forget the last question you asked, but yes.
So you have followed a lot of people who go to those, giant competitions, right? And if we're going to use the same vocabulary you use, what makes a gifted hypographer? And I'm asking this question in the context that there was a little bit of, you're sort of implied through your talk that, there's an entire nation that would be particularly gifted at prompt engineering due to the way that they've had to learn to think about typing.
Yeah, and I'm not sure that they would necessarily be a giftedness in it. It's more that it turns out that when you have all of your third graders take chess as like a class in school, you tend to have more grandmasters in Russia than in other places. It doesn't mean the Russian mind is somehow conducive through culture or genetics to chess. It's that it turns out that when there is at an aggregate level something like that. And I don't think there's a way to. That's a hunch. That's a venture, I would say, more than an argument. But it would be almost impossible for me to imagine how 600 million, 700 million, 800 million people who get up in the morning and immediately start hypographing, just like if they're good or bad or whatever from it, percolates or sort of effervescently percolates the same kind of possibilities as another 600, 700, 800 million people who are still really drinking, I'll call it Kool-Aid just to be a little provocative, of the myth of immediacy, the myth that like the actual goal of human-computer interaction is kind of not to interact. I'm going to go so far as to say I don't think there is such a thing as human-computer interaction, really. I think that human-computer interaction, in some real sense, begins only when interaction and the recursiveness of it is actually a theorized part of the process. There is a realm in which what is being called human-machine or human-computer interaction in some context really is command and response. I mean, has anyone ever been angry at like Siri? Like when doing text? Is anyone ever like viscerally been angry that it like got the thing wrong?
Yeah.
That's not human-computer interaction. That's master-slave interaction. That is, I have this intention, I'm uttering it out loud, and you're getting it wrong. I don't want feedback. I don't want a question back. I don't want interaction. In another model.
It's the same thing when I talk to, I won't say who, But you have people you talk to when you get the wrong kind of interaction. How is that different?
Well, I'm not sure that there's a desire for interaction. That's the key. It's not that there's a higher or lesser quality of interaction. It's that the nature of the interaction is one in which it's supposed to be transparent, immediate. It's supposed to become that. And that, it turns out, is effectively what we find in the case of Ming Kuai. I didn't go into Sinotype, but by virtue of having to think about mediation, not sweep it under the rug, not put it under the hood, but like make it an active part of the world that it already is. It's not just making it a part of the world, it's admitting that it's a part of the world and then thinking about it very hard. That although it has all of these additional steps and recursive loops, what it also means is that the sheer power of the device that's sitting in front of me right now, which according to the definitions of 1980s and 90s, like COCOM, the US government would have been considered a supercomputer that would not have been allowed to be sold to Moscow. It actually takes advantage of that kind of firepower, computational power, whereas a commitment to immediacy is in effect trying to recreate the experience of a Remington typewriter that doesn't hurt your fingers as much. Like you don't have to push as hard, but we're trying to make it so what you type is what you get. But in doing so, it becomes an supercharged typewriter, as opposed to a thing that actually does have the capacity to say, which of these 8 things do you want? And let me recurse with that. I don't know if you had a follow-up or text.
No, I'm
Yeah.
sorry to bring you back before. I'm sure you have an amazing question, but I kind of wanted to go back a little bit to what makes a gifted typographer. So because we talked a lot about the machine and about the system, in your experience. So
the answer is I don't know. I really don't know. Yeah, I don't know, and I'm not sure that.
Because
I mean, it
people
could speculate as to what it
competitions,
is.
right?
But you could speculate as to what it is for typewriting in terms of what made a spectacular typist in the mechanical realm. It's possible to sort of archivally reconstruct it. So, for example, unlike a skilled typist in English or French or Italian or German, where you're supposed to be able to look at a primary transcript and not take your eyes off of it and be able to type blind, faithfully. That's a feat of, that's amazing to be able to do that, but that's the idea. For a Chinese typist operating in the 30s and 40s, what would have made someone a much better or worse typist is actually investing in the skill of peripheral vision and anticipation. It's a little bit like a billiards, what makes a good pool player. A good pool player is ready for the next shot. And so you take a shot in order to set up the next shot. And if you can make a shot, but leave yourself in a bad spot and then be impossible to make the second shot. But a good typist will actually come at the character they're looking for, ready to sort of veer to be ready for the character that they know is over on the right flank. And so suddenly peripheral vision, anticipation, you could liken it to a billiards player. You could liken it to a person who knows that if you're going for a double, you have to scoop out and round first base differently than if you're just running to beat the throw. It's a different kind of muscle alignment. In terms of typography, the point of the book, I think at the end is, reader, if you believe the argument, if you're convinced by the argument, then really the argument is there is this, we are in the incunabula period, to use a sort of Gutenberg idea. We're in the first 50 years of a new age of writing. We're in a new age of writing because this transcript, let's see, this transcript back in this one here, the transcript on the bottom of what this person actually typed to win this competition, scaled up against all Sinophone computer users just churning out text on a whatever basis. At this moment, that can be localized. That's a very large number, but it's kind of one subset of the computing world. As more and more people enter into a relationship with computers where they are not typing anymore, their prompting, then this is the future, not a weird cul-de-sac of human-computer interaction. And so we don't really know, we haven't theorized typography. We've theorized orthography and whatever this era of writing we've been living in ever since cuneiform and so forth. We don't really have a vocabulary yet to really think through this. So I have no answer for what makes a good typographer. I just know that what makes a good typographer, chances are, is not what makes a good orthographer. It's not the same. Yes, I'm sorry, yes.
Yeah, I would say it's similar to sports figures in terms of there's probably posture and coaching you can get. And then, of course, you have to have some aptitude for it. And I imagine it's similar in that way. But the comment I wanted to make, first of all, I accept the implication that the relationship I really wanted with the person was master-slave. I think that's a good possibility. But on the other hand, I wonder, you're describing the master-slave relationship in terms of the typography in ways because you know what's happening under the covers. But for the person who's interacting, for the people, for example, who believe Siri is real, who think they're interacting with something that's humanoid, if not human, there might be a different interpretation there because they don't know what's happening. They just know, they think they're actually working with an individual or something that has psychology.
Right. I mean, but I think that if it's interesting because I kind of come with you, halfway on the journey, and then I would just maybe bring this issue up. Like, how many times in an average day do you say something to another person and they mishear you, or they, and it's like,
Yeah.
wait, you want me to? So you said 7:30? No, 6:30. Oh, okay. It's like we are constantly missing each other and correcting and doing it, and unless someone's just gone, has decided I'm not part of society anymore. Like, we have huge bandwidth of tolerance for, that's just understood as being the way it goes. But suddenly it's, I'm not going to say it to summon Siri to my command now, but hey, blah, 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 text, I'll be, do you want 2% or do you want whole milk? And it's like, okay, I'm about to send, do you want 20% or do you want Whole Foods? It's like, no, there's no, oh, hey, ha, ha, ha. I get, yeah, I see that those are related. No, what I meant is this. There's no space for that. It's either get it right or it's truly understood as a failed interaction. And that's the thing that I really would be very eager to understand in sort of 21st century thinking in HCI is, what is an HCI in which that bandwidth tolerance recursive quality is explicitly part of it, and even in science fiction, and think about how many times you can sort of oscillate between when Iron Man is telling Jarvis to do something and it's a command and Jarvis always gets it right. But then there's these other moments where I don't want Jarvis to do anything. I want to have a conversation with a person, but it's still Iron Man who gets to decide and toggle between which one of these kinds of interactions do I want. But, Jarvis, if I want you to give me a map of the city and then overlay the holograph of this, it's just this seamless, just Jarvis gets it. There is never a moment in which Jarvis says oh, sorry, you want New York or Detroit? Or it's like, New York, I'm in New York. Of course I'm in New York. It's never like that. And so, but this is a zone, and to the earlier question of what are the implications when human-computer interaction either does or does not have this, to me, would seem to be a core element of what makes something a human X interaction, is this bandwidth for error, recursion, checking in, double checking, did you mean? What does it mean in a certain context in which, not out of cultural proclivity, not out of some sort of deeper meaning, but because of the curious trajectory of 19th and 20th and 21st century technology, That's actually baked in. That's baked in at the core level. And in another sort of technical culture, where it was quite deliberately baked out of the recipe. Not accidentally, it was explicitly baked out of the recipe. That's an open question, but I think it's one that will have serious implications.
Were there any questions on the Zoom?
No.
Nope.
Awesome.
Okay. Any last words?
Just a really quick informational question is, so you presented at the beginning that 2013 competition, right? And the figures that there were for Chinese. What do those numbers look like today in 2024?
Well, I mean, once we lift up the top of human intention, where's the ceiling? I mean, I can prompt and say, give me a 1,000 word essay on this, and I can wait, and I can calculate the amount of time, and I can have something, and in theory, that's 13,000 words a minute. It's 15,000, it's 20,000, its typography can no longer be measured in words per minute. Words per minute ceases to exist in the hypergraphic age. The other thing that ceases to exist, which is very, very strange, had hypography existed, I don't know, in the chanceries of Europe, we wouldn't have the lowercase. If hypography had existed in Japan upon the first adoption of Chinese characters into the language, there would be no kana. The simple reason being is that the origins of both of these things are about the steady kind of calligraphic degradation and reformalization of the Roman capital or the kanji character. But if we imagine an alternate universe in which that writing, the purpose of writing the lowercase a, which is of course a calligraphically kind of degraded capital A, what if the point of the lowercase a was not to write the lowercase a, but to retrieve the capital A? That if the A had just been hypergraphic, the A would exist in the realm of the hypergraph, but it would never exist in the realm of the orthograph because it would always be computationally resolved to the thing being retrieved. And so the other thing that is weird is, except in computers in companies and governments in China or elsewhere, this does not anymore, this part here doesn't play a role in the evolution of writing anymore, because it doesn't live long enough to degrade into the minuscule or into kana. So the other thing about hypography is that the kind of evolution of writing, the evolution of writing hasn't changed, but it stands to reason that hypography might morph the laws of that evolutionary change in ways that can't be predicted yet.
Yeah, just with respect to kana, Japanese culture has a really strong sense of being Japanese or being external to Japanese, and that's where the katakana comes from. Foreign words and things like that being a part of the language, but not native to the culture. So, and I think there's some element too in the case distinctions in words, because it is important to distinguish certain words.
It is once there's a case system, but for example, all of the letters of the kana alphabet come from kanbun, when full Chinese characters were used for their phonetic value, and then literally over the course of centuries and centuries of writing it, kind of like the chancery script of people just writing the capitals faster and faster and faster, that you write these kanbun Chinese characters for 500 years faster and faster and faster, and the character an for peace becomes an the kana character. The character he becomes wa, and so forth over this calligraphic degradation, in the same way that the capital A used to be stroke, 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 and then someone abbreviated to stroke, 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 and then stroke, and left the brush down, and that's the lowercase a. And so there's this question of, what if the lowercase a, imagine a hypergraphic world in which one can on their trackpad write the lowercase a, but the input system is searching for the thing you're looking for, which is the capital A. That capital A is what's going to get sent in the email or printed out on paper and become the lasting record of that language. The lowercase a, in this case, would never, in a sense, become a lowercase a, because it would never have its own independent existence. it would be thrown away the second it achieved its objective as a hypergraph. So it's sort of there's like this underbelly now of the evolution of writing, which, except for surveillance operatives and companies doing quality control testing on their input systems, is not available to the average human person. The average human person will never ever see this transcript for as long as they live.
But then all of our texts would be shouted, because it would be all uppercase.
No, but they wouldn't be shouting because our very concept of writing would be different if we had never ever seen it happen. I'm happy to
You took my joke.
I'm happy to do it. I'm happy to do it.
All right, on that happy note, please join me in thanking Colin. So fascinating.